Maximising the energy and carbon efficiencies of transportation could have a tremendous impact on greenhouse gas emissions and provide a sustainable energy future beyond oil. At Purdue University, Indiana, scientists are engaged in systems-level interdisciplinary research to find solutions to these grand challenges.
When you look at transportation, there's only really one energy input, and that is oil. So 40% of the energy inputs in the US come from oil, and 2/3 of that is imported from foreign sources. There are national economic security implications of that. We have a grant from the Department of Energy's Office of Science for an Energy Frontier Research Center, and biologists, chemists and chemical engineers have come together to work on using plant materials as a source of fuel for liquid transportation fuels. And what we want to do in this project is to be able to substitute that barrel of oil with a barrel of lignocellulosic biomass, so plant material that is sustainable and renewable.
There are over 150 faculty at Purdue working at the Energy Center in Discovery Park, the university's $750 million adjunct campus for interdisciplinary research. Scientists and engineers are working to develop sustainable and renewable energy technologies, including C3 Bio, direct catalytic conversion of biomass to biofuels.
You start with a solid piece of biomass, let's say a corn stalk, and you want to turn that into gasoline, something you can put in your car and the car will go. Problem is that the chemical structure of the biomass has the wrong composition. We heat this material up very quickly in the presence of another compound, hydrogen, and the hydrogen reacts with the oxygen to take the oxygen we don't want away, and what's left is gasoline-like material. The big advantage of the approach that we're on in the C3 Bio is that we're going to start from biomass. We're going to turn that into fuel. The fuel is combusted to make CO2. The biological process will take that CO2 back into biomass, and we have a renewable resource for driving the energy needs of society.
2 new biofuels are currently being tested for aviation engines at the university.
They are Fischer-Tropsch fuels and hydroprocessed renewable jet fuels, which are both approved for blends up to 50% with jet fuel. This test facility allows us to actually see how they operate in a jet engine, as we see behind us, and we can also examine and evaluate the exhaust emissions produced by the engine. And then we also have a laboratory upstairs where we can see how the fuel interacts with materials to determine if there's any negative impact on gaskets, seals, etc.
Students are also inspired to develop innovative technologies and seek careers in electric vehicles through the Purdue Electric Vehicle Grand Prix, a collegiate all-electric go-kart race.
The EV Grand Prix is an event that we developed about 2 years ago in order to provide our students with the opportunity to have actual hands-on experience in building some of the new electric vehicles of the future. It's an excellent way to teach practical electrical mechanical engineering technology, allowing students to take their classroom learning and put it into a very practical situation where they have lots of fun.
Efficiencies are needed in engine performance. Heavy vehicles also use fuel in braking systems and can't brake with an electric battery. Redesign is needed if hybrid technologies are to be used in heavy vehicles.
Imagine we have improved the efficiency of bus by 50%. The amount of energy saving we get by bus is equal to the same amount of energy we save by using 20 passenger cars. So this is a significant amount of energy that we can use. By using this technology and improvement, we can save approximately 15 billion gallons per year of fuel consumption and also 155 million tons of carbon dioxide emission.
Systems approaches to transportation are also being developed to highlight where the greatest efficiencies in energy consumption could be made.
If you synchronize traffic lights, for example, you can cut down people's wait time. Now that makes them happier, but it also causes them to use less fuel in idling. Let's synchronize the lights. Let's make the lights support the best traffic patterns, that helps cut fuel costs. Utility companies are very interested in transportation getting mixed with the energy system. So we're doing work with an Indianapolis utility company to figure out how battery-powered vehicles and hybrid electric vehicles are going to change the load on the grid over the next few decades, especially as you get higher and higher penetration rates of these new types of vehicles.
Scientists and engineers are working to deliver fuel switching from oil, electric and hybrid vehicles, improvements in ground vehicle power and jet engine performance. The discoveries in energy research today will drive forward a new carbon neutral and energy efficient transportation system.